Hey everyone, I'm trying to do my cartoon version of I guess how we perceive creation from the basis of science, the scientific creation story, which we have been talking about this week, and most of you have been able to see the video, and if not, you can certainly follow the story from the Big History website. But I want to make some points about what they're doing in the video that you've watched this week that wouldn't be obvious from the outside. So here we go. I'm going to give you, not able to, okay, let's do it this way. Okay. What I want to do is give you basically their story, the story of creation, but with a slightly different twist or twists. And so basically, down in the bottom, whichever direction that in corner, you'll see the blue sort of little explosion, which is, so in the video, you have these 8 what they call transitions, important transitions, where complexity increases sort of suddenly. And in each case, they tend to use the words that there was a lucky break. It was a lucky break. So these are the lucky breaks, but I'm going to put slightly different words on them than they do in the video, but you can follow along. You could put their words on and it'd be fine if there were 8 of these blue stars. So this is basically the story of creation from a scientific perspective. So down at the bottom there, okay, and I'll say more as we go, but this is how creation proceeds. So it goes like this, okay. Okay, so now each of these blue explosions is a explosion in, say, complexity. But I'm going to put these names on them. Now, so this is not currently, with time, it's how we explain things in science, and the way that science currently works, mainstream science that is that it explains things from the bottom up. So the world is built up from its smallest parts, right? So we start with subatomic particles, which then make atoms, which then get together to make molecules, which when you have organic molecules, eventually they get together to make cells, and life starts. And then cells get together to make multicelled organisms. And multicelled organisms eventually give rise to humans. So this is just a real cartoon, brief version. Now, I know these aren't the same categories that they have in the film. These are the categories I'm making, and these categories are certainly in there. It's just that they've used different designators. Okay, so this is the direction of causality as far as modern science is concerned, from the bottom to the top. So subatomic particles are responsible for atoms, which are responsible for molecules, cause molecules. Molecules cause eventually cells. Cells eventually cause multicelled organisms, and multicelled organisms eventually cause primates and humans with brains, okay? So I might have to move this window, actually, because I know something's going to happen up there. Okay, so, you know, in creation, okay, we can replace causality with time, so that we can say that at the beginning of the universe, the first things that formed were subatomic particles. And then the next thing were atoms, hydrogen atoms. And then the next things were molecules made in stars. Eventually stars made planets and organic molecules, and cells formed on those planets. And then cells eventually got together to make multicelled organisms, blah, blah, blah. And then this whole thing, you know, is 13.8 billion years, the history of the universe, essentially. Okay. So time or causality, it doesn't make any difference as far as science is concerned. It's the history of the universe recapitulates what happens, what is true in any given moment, basically. Okay, so the truth in this view, the truth is unitary, basically, because ultimately there's only one thing, and that is the substrate of matter. And matter then goes forth and climbs this ladder of complexity, creating these things. Now, each of these events may be regarded as improbable or a lucky break, but doesn't seem to me that they actually could be, because this is what happens in every moment, and it happens what happened over the history of the universe, basically. Okay, so then our story goes, as we climb up this ladder and we eventually make humans with brains, there's this thing that arises, these things that are, well, arises at the top, and that's consciousness. And then at the bottom, at this point in time, we have quantum theory. So there's two areas, two ends, the two ends of this chain of causality or time are somewhat mysterious. So, you know, consciousness arises up here, and then consciousness sort of looks back, digs in, and finds that quantum theory is responsible for, at the base of things, for everything that makes up this whole chain of causality or time, basically. And so time would be like roughly 14 billion years to go through this sequence, starting with subatomic particles after the Big Bang started to cool down, basically. And then there's this kind of mystery that occurs, which is that consciousness, well, okay, here goes. Consciousness has a mystery to it. So does quantum theory, because we don't know how to interpret it. And then there's this mysterious connection between consciousness and what goes down with the subatomic particles. And so that's sort of a mystery. But basically the story is that we have this chain of things in which basically everything is explained, because this chain explains everything. But at the two ends, there's a sort of a bit of a mystery, and then the connection between the two ends is a bit of a mystery. Okay. Well, then it turns out that actually between these levels, there's also mystery. So this jump that goes between molecules and cells is where this question mark is right here, is where life forms. Well, we don't know what life is, basically, and we don't know how it forms. And what we say is that we know in principle how it formed, but basically we actually don't know how it forms. So there's another question mark. And what you find is that there are question marks everywhere in the scheme, even though we pretend that there aren't. So how subatomic particles lead to humans with brains ultimately has plenty of mystery in it, even though we pretend it's all explained. And I'm sure it would have seemed like watching that movie that everything is explained. The other thing is that what we're talking about here with all of these entities that came out of the Big Bang, we have to remember that because of dark matter and dark energy, this only comprises 4% of the universe, basically. The universe is 96% unknown because it's composed of stuff that we don't understand, but that we infer to exist. We infer dark matter and we infer dark energy, and we can talk more about that if you like. Okay, so what I want to say here is that this sequence really reflects a kind of new science that's called complexity theory. And the complexity theory more complex things arise, basically, by the combination of less complex things, okay, in complexity theory. So, but the new thing that arises has very different properties than the entities that went together to make that thing. So if you see, for example, here, between molecules and cells, obviously cells have very different properties than molecules. In fact, cells are alive. And so there's this kind of jump in complexity. And in complexity theory, the single-celled organism is what's called an emergent phenomena. It emerges from the interaction of organic molecules, basically. Organic meaning that they contain carbon, basically, when a molecule is organic. So, so there's these things called cells that arise that have really, really different properties than molecules do. They do really different things, and they're much more complex, and they somehow kind of pop out. There's a sort of a creation step here that goes on. Simply in the interaction of organic molecules, somehow cells arise, right? And then the same between atoms and molecules. And we could talk about, for example, water. So water, H2O, is a molecule, basically. 2 hydrogens and an oxygen. So it's formed from atoms of hydrogen and oxygen. So the atoms of hydrogen and oxygen are more simple things, and they get together and they make this thing called water, the molecule of water. Well, now hydrogen and oxygen have physical properties. The elements, hydrogen and oxygen, have physical properties. But when they get together and make this thing called H2O, it has really different physical properties, right? All the properties that we know about of water are created. They pop out of this interaction between atoms. And what I want to say is that, so that's an emergent, there's emergent phenomena, the emergence of water and all of its properties emerges out of the interaction of hydrogen and oxygen. Now, we might think that all of this step here is explained. Well, we know how hydrogen and oxygen bond, and it then makes water, and then water has the properties that it does. The problem is that the properties of water, all of the properties we know about water, basically its physical properties, its ability to flow, and all of the kinds of properties that water has, aren't actually predictable from the properties of hydrogen and the properties of oxygen, right? So you can't start from first principles, put hydrogen and oxygen together theoretically, and then come up with a prediction of the water molecule. You can't do it. So, and that's why it's an emergent phenomena. But what you can do is one can look back down the chain and say, oh, I see how that happens, right? So from first principles, I can't put, I can't write a theory that will combine hydrogen and oxygen and give me something that has the properties of water. From first principles, I can't do that. But looking backwards, I can explain it, if you see what I mean. So looking back, in retrospect, I can explain it. So here, going to cells, I can look backwards and I say, well, I can explain how molecules get together and form cells in retrospect, but I can't start from first principles and predict the existence of cells from the existence of organic molecules. I can't do that. So what this means is that looking up this chain, there's this element of unpredictability. I can't predict water from atoms of hydrogen and oxygen. I can't predict the properties of molecules, basically. And I can't predict life from the existence of molecules, particularly organic molecules, and so forth up here. From multicelled organisms, I can't predict that there would be these things called humans that would have consciousness, looking up the chain. But when I look back down the chain, I say, well, yes, I can see how that happened, if you see what I mean. So it's this weird thing where actually these explosions in complexity aren't actually predictable, but they are explicable. if that is understandable. And I actually think there's a strange kind of sleight of hand there that goes on with science. It's like we act like things are explained, but in between each one of these stages, there's actually something unexplicable that happens, right? And which results in the stage being unpredictable. But looking back, we can say, "Oh, we explained it. We can explain it in principle. We can explain it." It's usually the word. So I wanted to make that point that, and it relates to the discussion of randomness and that kind of thing. It's like randomness is not the same thing as predictability. So these things are not apparently not random. These steps are not random, but they're not predictable. So I say something's unpredictable. It doesn't mean that I'm saying that it's random, basically, because these most certainly aren't these steps most certainly aren't random. Okay, so random is something that occurs within each of these levels, I would say. The property of things being what we would call random. So of course, something that is random is not in principle completely predictable. You might be able to assign probabilities to things, and this would go into chaos theory, but you can't predict, basically, exactly predict. There's going to be uncertainty in what is going to happen, basically. So this step from atom to molecules, I don't think we would say that these steps are actually uncertain, that they're fraught with uncertainty. I think they're kind of destined to happen. But in other elements of physics, then there is this element of uncertainty and unpredictability, such as what happens at the quantum level, basically, with, we don't know where exactly the location of something will turn out to be, but we could, a subatomic particle, we don't know, but we can assign probabilities to its location, that kind of thing. That's how quantum theory goes. So I'm just trying to give you this perspective, which is the perspective of emergence, basically. Phenomena emerge, and they're implicitly unpredictable, but they're at least appear to be explicable in retrospect, looking back down the ladder from where we stand, looking backwards. They're in principle explicable, but they're not predictable. We never could have predicted that cells would have arisen from molecules, and there's no way to currently do that from first principles to predict that molecules would get together and form cells. Organic molecules we couldn't do it, and so there's this element of things appearing to be explained, but really not being explained. And so the creation that occurs down here in the Big Bang, where all of this process is created, kind of occurs in every gap here. The process of creation happens in every gap on this ladder up. The same with the movie that you saw. So the process of creation, every one of these transitions, process of creation steps in and does something that's unpredictable, that we now say that we can explain, but we never could have predicted. And what I say is that means it's not explained. That if we couldn't have predicted it, then we haven't actually really explained it. It's just something that happened. And basically what we have to say is, oh, well, that's just something that happened. Or we can say, well, the conditions were just right. They just happened to be just right so that organic molecules would get together and make cells. We could say, oh, the conditions were just right, and that was a kind of cosmic lucky break. We could say it that way. But basically what that means is we haven't explained it, right? At least in the strict causal way that we imagine that we explain things. So, and I do want to say that it's very clear. So we treat science as being bottom up, basically. Science is everything is the sum of its parts, right? It's like we can explain something by the parts that make it up, okay? So that's called reductionism. So complex things get reduced to the simple things that they're made of, okay? But it's very, very clear that there is a kind of top-down causation as well. And hence this connection between humans and subatomic particles. But obviously humans affect other multi-celled organisms, right? Which also affect cells. And so there's definitely a kind of a causality that goes back down the chain that isn't really recognized by science, okay? But there are scientists that are pointing this out, that you can't just have bottom-up causation because there's also top-down. And once you get top-down as well as bottom-up, then you end up in this kind of weird loop where the more complex things were caused by the more simple things, but the more complex things are affecting the simple things. And so which is affecting the more complex things and so forth. It's like a sort of weird kind of feedback loop or something that you get caught in, and that consciousness may have affected the Big Bang. You see what I mean? You get caught in this. So I just want you to see this. I don't know if this has made any sense. I hope that it has. And we'll, let's see, I want to stop this recording, and then I'll record more on top of this. And hopefully that was clear. If it wasn't clear, then like fire tons of questions at me, because I could probably do a better job of explaining that.